Limits of infinity and properties of limit. So today we are discussing properties of limit and how we use these limits in getting vertical and horizontal asymptote. Now, limits of infinities and properties of limits. Now consider the line x equals c, where c is constant. Now this is, you consider this as a vertical asymptote. Now x equal to c is constant. Now consider this as the vertical asymptote. Now consider the graph of function y equal to fx. Now this is the graph. Now we know that in limits, see, in limits, limit when it tends to c plus means when you are approaching limits from the right hand side, c plus fx, so that is equals to infinity. And when limit x tends to c minus, that means we are approaching the limits towards the left hand side. We also know that left hand limit is equals to infinity. That means limit x into c plus this fx, the value of the function will tends to infinity. Now for the horizontal asymptote, let line consider line y equals to k, where k is a constant. So this line y equals to k, where k is constant. This is actually a horizontal asymptote. The graph is y equals to fx. Now applying the limit as x tends to infinite. So the limit as x tends to infinite plus x tends to infinite plus the value of function fx will tends to k. K is what? where there is a where they have the horizontal asymptote. So as x tends to infinity plus, when we are moving from the right hand side, that is equals to k, and when limit x tends to infinity minus, fx will tends to k. So that is for the horizontal limit, sorry, for the horizontal asymptote. Now students, if you like the video, please do like and subscribe to our channel, and also press that notification bell icon to watch our latest videos. Thank you. Now we have oblique asymptote. You can also follow me on Facebook. I am on Facebook as Dinesh Nayal Classes. Oblique asymptote. Now any rational function, now consider rational function fx by gx. So this any rational function fx by gx. Now see, where the degree of gx means where the degree of gx is 1 less than the degree of fx. In this case of a rational function, we have an oblique asymptote. Is 1 less than the degree of fx. So for example, you can take x square plus 1 by x. As you can see, this x has this one has a degree 2, this one has degree 1, so this is 1 less than this. And to find an oblique asymptote, you do the actual division, and whatever you get the quotient, that is the oblique asymptote. So in this case, if you divide, you get the quotient as x. So y equal to x will be the line which is an oblique asymptote of this. Now coming to the question, it is given that limit, you have to evaluate this limit x tends to 0, 2 plus 3x whole square minus 4 bracket 1 plus x whole square whole upon 6x Now see, first of all, what we will do is that we are going to expand this first. For this limit, we are going to expand the above. So limit x tends to 0. This will be a square, which is 4, plus twice of ab, which will be 6, 12x, plus 9x square. And minus, in bracket, this will be 1 plus 2x plus x square. Expanding this, whole upon 6x. Now solving this, we get 4 plus 12x plus 9x square. And this will be minus 4 minus 8x minus 4x square. Now solving all this, limit x tends to 0. So this will be 9x square minus 4x square is 5x square. 12x minus 8x is minus 4x. Plus 4 minus 4 will get cancelled. They get cancelled out upon 6x. Now see, we can take x common from here. So solving this, limit x tends to 0. Taking x common, so this will be 5x plus 4 upon 6x. So x and x will get cancelled. Now we can apply the limit. Now applying the limit means putting x equal to 0. That means 5 into 0 is 0. We are left with 4 by 6. So 4 by 6 is actually 2 by 3. That's the limit, the value of the limit. Now the next question. It is given that limit x tends to infinite minus x square plus x plus 2 whole upon 3x square plus 2x minus 1. Now see, for the limit x tends to 0, the one thing that I must like to tell you is that, see, you see the denominator and the highest power of x in the denominator, you divide throughout. So highest power is x square, so dividing throughout by x square, so which is minus x square by x square plus x by x square plus 2 by x square. Now whole upon this will be 3 by x square by x square, 3x square by x square plus 2x by x square minus 1 by x square. Now see, solving this, actually this becomes 1. This becomes, writing limit x tends to infinity, this becomes 1 minus 1. So this will be 1 upon x and 2 upon x square. This will be upon 3 plus this is 2 by x minus 1 by x square. Now when we apply the limit, we see 1 upon x and 1 upon x square term, they all will become 0. So we are left with minus 1 by 3. So answer of this is minus 1 by 3. Minus 1 by 3, that's the limit. Now, question. Now the next question. See, by using limits only, you have to find the vertical and the find vertical and horizontal asymptote of asymptote. Now the equation is, they have given 3x upon 6x minus 1. Now see, for the vertical asymptote. See, for the vertical asymptote, we have learned that solution for the vertical asymptote. For the vertical asymptotes, we know that as limit x tends to a, where a is any constant. So this fx tends to infinite, means the value of the function will tends to infinite. That is plus minus infinity. So the value of this function tends to infinite. So you can see that for this function 3x upon 6x minus 1, this will tend to infinity when 6x minus 1 is equals to 0. So that means x is, if you solve it, x is 1 by 6. So x equal to 1 by 6 is the vertical asymptote. So the vertical asymptote is x equals to 1 by Sx. Now solving for the horizontal asymptote. Now see, for the horizontal asymptote, for this 3x upon x minus 1, as limit x tends to 0. Sorry, the limit x tends to infinite. Here for the horizontal asymptote, you know that 3x upon 6x minus 1. So now we will divide the numerator and denominator by the highest power of x in the denominator, which is x only. So doing limit x tends to infinite. So please remember this in horizontal asymptote, limit x tends to infinite. 3x by x, highest power, 6x by x, minus 1 by x. So solving this, limit x tends to infinite, and this will be 3, x will get cancelled, it will be 6, x will get minus 1 by x. Now applying the limit, 1 by x will become 0, 3 by 6, that equals to 1 by 2. So this is the horizontal asymptote. As well as you can use this method to find the horizontal asymptote. So the horizontal asymptote is 3 by 6, which is equals to 1 by 2. So what do you write for the horizontal asymptote? Y equals to 1 by 2. Now, the last question of the day. Again, the question remains the same. Find the vertical and horizontal asymptote using the limits. And the function is 1 minus x cube upon x cube minus 1. So we know that for the vertical asymptote, this function will occupy the for the vertical asymptote, this function will have the infinite value when x square minus 1 is 0. So for this, again we are doing the same thing. Limit x tends to a or c plus fx, where c and a both are constant, tends to infinite. So value of this function tends to infinite when x cube minus 1 is 0. Yeah, x cube minus 1 equals 0. So solving this, we get x equals to 1. So vertical asymptote is x equal to 1. Now for the horizontal asymptote, see, we have limit x tends to, we know that the horizontal asymptote x tends to infinite. So this is 1 minus x cube upon x cube minus 1. So dividing throughout by the highest power of x in the denominator, which is x cube. So dividing throughout by x cube, dividing both numerator and the denominator. So limit x tends to infinite. So 1 upon x cube minus x by x cube minus x cube by x cube. Again upon whole upon x cube by x cube minus 1 by x cube. Minus 1 by x cube. So solving this goes limit x tends to infinite. So that will be 1 by x cube only. This will be minus 1 by x square minus 1. This is 1 minus 1 by x cube. Applying the limit. See, 1 upon x terms, whether it is x square or cube, they all will become 0 since they are infinite. So we are left with minus 1 by 1. So the horizontal asymptote is y equals to minus 1. Horizontal asymptote, y equals to minus 1. So that's our answer.